Hi, in this video I'm going to do a proof of Kepler's third law, and I'm going to show you how it can be used to find the mass of the planet Earth, okay, or of other planets. Okay, so we learned that the force of gravity is big G, the mass 1, mass 2, divided by r squared or d squared, it depends what we did. Okay, and we also know that this force of gravity is what keeps planets go around the sun. So let's just say that one of these m's is the mass of a planet, this m is the mass of the sun. Okay, and so this is the centripetal force, the net centripetal force. So this is going to be m of the planet, the v of the planet around the sun, divided by mv squared over r. Yeah. Okay. Now, I'm going to try to simplify that to get an expression for the speed. So I can get rid of that. I can get rid of the mass of the planet. Okay. I can get rid of 1r here. Okay, so v becomes square root of g, the mass of the sun divided by r. And this can apply to moons going around the planet. So this mass here will be the mass of the planet, not the mass of the moon going around the planet. And I think I explained this in the past that the v is independent of the mass of the planet that's going around the sun or the moon going around the planet, because technically they are falling. So the sun, the earth is falling around the earth is falling around the sun. Okay, so you're not going to see the mass of the planets in there. You're just going to see the mass of the sun. If you're talking about moons going around a planet, you're not going to see the mass of the moon, you're going to see the mass of the planet they're going around. Well, assuming a circular orbit, v is distance, which is 2 pi r over the period. Okay, so now let's see if we can manipulate this a little bit. I'm going to square both sides. So if I do that, this is gone. This becomes a 4. This becomes square. This becomes square. This becomes square. And then I'm going to bring the r and the t together. So I'm going to multiply both sides by r. So this becomes r cubed. Okay, and I'm going to bring this 4 pi squared down here. Okay. 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 So let's see. So basically this means r cubed over t squared is equal g, the mass of the sun, divided by 4 pi squared. And this is a constant. Okay, g is a constant, the mass of the sun is a constant, and the bottom here is a constant. So this is a constant, which means r cubed divided by t squared is constant, which means that if I do r cubed over t squared for different planets going around the sun, this should hold. And this can go on forever, okay? Depending on how many planets you have going around the sun. Okay, so that's Kepler's third law. That's the proof to it. And I can manipulate this to look like what we have in the formula sheet. Now, let me try this to show you how we can find the mass of the Earth. Okay. So now instead of dealing with the mass of the sun, I'm going to put the mass of the Earth here. Okay, and t is the period of our moon going around the Earth. So previously I could have found the mass of the sun. Okay, how do I do that? Well, I just need I can use the Earth as an example. I can do the radius, okay, of the orbit of the Earth, meaning the distance between the Earth and the sun cubed, divided by how long it takes the Earth to go around the sun. Okay, I have to change that to seconds. These are known values, and I can find the mass of the sun. Well, if I want to find the mass of the Earth, okay, I can basically take something that goes around the Earth, okay, and take that information and put it in here. Well, we know what goes around the Earth. We know that our moon goes around the Earth. Or we can take one of our satellites that are going around the Earth and use that. So the r will be the distance between the moon and the Earth. center to center. The t is the time it takes for the moon to go around the earth, which is a known value. And I think if you know these values, you know pretty much everything here, and you can find the mass of the earth. And that's pretty much how you can find the mass of the earth. All right, thank you.